Welcome back, everyone. In previous videos, we've introduced this language called C, and we learned how we can write a simple Hello World program, how we can compile it, and how we can run it. Then we looked at libraries. We used functions from the standard C library, like printf, and then we installed a third-party library, where we got access to functions like getInt and getString to help us get input from the user. We then looked at variables and data types, and in this video we're going to be putting all of these concepts together in our examples as we talk about conditionals and Boolean expressions. We've already seen some examples of conditionals and Boolean expressions, albeit not in C, but in pseudocode, where we looked at an algorithm to search for a word in a dictionary. If you remember, in our pseudocode, we essentially asked the question, if word is on the page, and if this Boolean expression of word is on the page is a true statement, then we would print the definition of the word. However, else if that statement is false, then we would flip to the next page. This is exactly what conditionals are going to allow us to do in our code. We're going to have the ability to ask a question, and depending on the answer to that question, we can perform different actions or take a different path, so to speak. Similar to a fork in a road. And we also talked a little bit about Booleans. Booleans, again, are a data type that is either true or false. Thus, a Boolean expression is just an expression that will evaluate to true or false. And in our dictionary example, word on page is our Boolean expression. Let's see some examples of these conditionals and Boolean expressions. Alright, I'm here in my Ubuntu virtual machine. I'm going to go ahead and open up the terminal and we'll change directory into that tutorials folder. I'm going to type code space and a period to open up VS Code in this directory. I'll create a new file up here and I'll name this conditionals.c. And in here, we're going to do our standard boilerplate. However, we want to make sure that we include the CS50 library. So we'll do hash include stdio.h, and we'll also do hash include cs50.h. And again, I'm keeping these in alphabetical order, just for aesthetics. I'll do my int main and void, and our curly brackets followed by return 0. Now let's write a program that lets the user enter a number between 1 and 10, and if the number they entered is less than 5, let's print one thing, like you lose, for example. However, if they enter a number greater than 5, let's print you win. We know that we can get input from the user by including the cs50.h header file, and then using the getInt function to get an integer from the user. We'll store the value they inputted in a variable called guess, and we'll prompt the user to guess a number between 1 and 10. To do this, we can use the following code. We can say int guess, and assign that the value of getInt, and prompt the user guess a number between 1 and 10. So again, what this line is doing is this getInt function is going to prompt the user for a number between 1 and 10, and then wait until the user enters a number. When they do enter a number, the value is going to be placed in this variable called guess. The reason we're using this int before the guess is because this is going to be the type, the data type of the guess variable. Now, before we jump into writing these conditional statements, let's just print out the number that the user entered to make sure that this is working the way we want it to. And the way we would do this is by calling the printf function. And then inside these parentheses, we're going to type you entered. And now what? Well, we want this to say something like you entered 3 if the user entered 3, or you entered 4 if the user entered 4, and so on. And so we're going to want an integer to go here. And to do that, we use the %I format code as a placeholder. And I'll go ahead and preemptively add the \n, or the new line character. And now we need to tell printf what's supposed to go in this %I. And well, we're going to want to put the guess variable right there. So the user is going to be prompted for a guess, and I'll make sure to put a semicolon here. The user is going to be prompted to guess a number between 1 and 10. When they enter a number, that number is going to be stored in this guess variable, and then we're just going to print out you entered followed by the guess. So let's go ahead and save this, and we'll compile and run this. So I'll go back to my terminal, and to compile, we just write gcc-o conditionals and conditionals.c. However, since we're using this CS50 header file, we also have to remember to supply the argument -l CS50. And when we compile, we can see that we get no errors. So let's go ahead and run this. And let's enter the number 2. And we can see that it's working as we expected. It's saying you entered 2. Run this again. We'll try this with 7. And it seems to be working as expected. So now let's implement this conditional. And to do that in C, we would use the keyword if, followed by the Boolean expression we want to evaluate. In this example, we want to check if the number the user enters is less than 5. And this will be our Boolean expression. I'll type this out and then we'll break this down. I'll say if guess is less than 5, and then open up these curly brackets. Now the syntax might look strange, but you can kind of read this as if guess is less than 5. And when the compiler runs this code, it's essentially going to copy the guess that the user enters into the variable guess and evaluate this expression. For example, if the user enters 3, this is going to look like if 3 is less than 5. And is 3 less than 5? Well, yes, it is. And now whatever code we write inside these curly braces is going to run. However, if we entered 6, for example, well, now this is going to be if 6 is less than 5. And is 6 less than 5? Well, no, it's not. So we are not going to run the code that we have inside these curly brackets. So let's see this in action. Instead of printing out the guess after we get the answer from the user, let's check if the guess is in fact less than 5. Well, let's just print out something like you entered a number less than 5. To do this, we'll say printf, and then you entered a number less than 5. We'll add our \n and our semicolon. All right, now let's make sure that we save this, and we'll go back to our terminal. We'll use our up arrow shortcut to recompile, and again to run this, and let's guess the number 4. And you can see you entered a number less than 5. However, let's run this again and give a number greater than 5. And here we can see that nothing happened. And this is indicative of our if statement. If the guess is less than 5, we are going to run this code. However, if the guess is not less than 5, then we are not going to run this code. In other words, if this Boolean expression evaluates to true, we are going to execute the code inside the curly braces. If this statement evaluates to false, we are not going to run the code inside these curly braces. Now, I know the syntax for writing these conditionals in C might be a little intimidating at first. This will become second nature, And with this construct, we can check if a condition is met. And if it is, we can choose to do one thing or another. Now we also have this keyword else that we can use. And this will let us run some code if the Boolean expression evaluates to false. And the best way to understand this is by seeing an example. So we'll build upon what we've already got here. We know that this if statement is going to print if and only if the user enters a number less than 5. Well, we can add this else statement down here at the bottom, followed by some more curly braces, and then in here, this block of code is going to run if this Boolean expression evaluates to false. So this code is going to run if this Boolean expression is true. However, this code is going to run if this evaluates to false. So in here, we'll do something like printf, you entered a number greater than 5. And now we'll save this, and we can come back here and compile this. We'll recompile, we'll rerun, and again we'll enter the number 3. And it says you entered a number less than 5. Now let's run this with the number 8, and it says you entered a number greater than 5. So as you can see, when we entered 3, this is the statement that is being evaluated. If 3 is less than 5, and is 3 less than 5? Well, yes, it is. So that means this statement is true, thus this code block will run. However, when we entered 8, is 8 less than 5? No, it's not. So this statement returns false, thus the else block will run. Now, if you think about this question that we're asking a little bit, is some value less than 5? Now, obviously, the user can enter something less than 5, and we have a case for that. And a user can enter something greater than 5, and we have a case for that also. But what if the user enters exactly 5? Well, right now, we don't have any case for that. If we enter 5, then this Boolean expression is going to look like if 5 is less than 5. And is 5 less than 5? Well, no, it's not. So what's going to happen? Well, we know that this is going to evaluate to false. And if this Boolean expression is false, what do we know is going to happen? We know that our else block is going to run. So we're going to enter 5, and it's going to print back to us, you entered a number greater than 5, which doesn't make much sense. So how could we catch this final case? Well, this is where the keyword else if comes in, and we can use these as such. We can put the else if right in between our if and our else. So I'll type this out, but first I'm going to go ahead and erase this. And up here we'll say else if. Then we need to supply another Boolean expression, followed by curly brackets. And up here we'll change this back to is guess less than 5. So if the guess is less than 5, we're going to do this block. Else if, for example, the guess is greater than 5, well, if the guess is greater than 5, we'll print out what we already have. Printf, you entered a number greater than 5. However, if both of these statements, these Boolean expressions, evaluate to false, this else block will run. And so, what can we assume from this? If we're asking the user to enter a number between 1 and 10, the user can either enter a number that is less than 5, and this will run, or they can enter a number that is greater than 5, and this will run. However, if they entered a number that is not less than 5 and not greater than 5, what can we assume that they entered? Well, we can assume that they entered 5, exactly. Because there's really only 3 cases. The number is either less than, greater than, or equal to. So down here, we can say printf, you entered exactly 5. And this is going to read like, if the guess is less than 5, we're going to print this. Else if the guess is greater than 5, we're going to print this. Else, if neither of these cases are true, we're going to print this. And this is how we would represent a proverbial 3-way fork in the road, so to speak. In our case, the number that the user enters must be either less than 5, greater than 5, or equal to 5. And we could keep going with these else-if statements if we needed to. We'll change this around a little bit and ask the user to enter a number between 1 and 4. And we'll check if the guess is equal to 1. We'll just type you entered 1. Else if the guess is equal to 2, well, we'll just say you entered 2. And like I said, we can keep going with these else if statements. So I could do another one and say else if the guess is equal to 3. And if it is, we'll print out you entered 3. And we can do another one. Else if the guess is equal to 4, well, we'll print out you entered 4. And I forgot a semicolon. So now we're checking if the guess is equal to 1, we'll print this. If it's equal to 2, we'll print this. If it's equal to 3, we'll print this. If it's equal to 4, we'll print this. And we also had this final else block. Suppose that the user didn't cooperate and they didn't enter a number between 1 and 4. So we could say you entered an invalid input. And now if we come in here and we recompile this and rerun it, we can see guess number between 1 and 4. If we enter 1, we get you entered 1. If we enter 2, we get that. We enter 3. And I missed a \n right here. So we'll add that, we'll save this, and we'll come back, recompile. We'll say 3, and then we'll do this again. We'll say 4, and we'll go again, and we'll say 10, for example, which is out of the range between 1 and 4. So we'll get you entered an invalid input. Now, this double equals might have confused you a little bit. However, remember that I said in C, the single equals doesn't mean equality. It means assignment. And this is yet another example of how the creator of C kind of ran themselves into a corner. They chose to use the single equal symbol as assignment. So when it comes to equality, we'll need a different symbol. And it turns out that the symbol the creators of C chose to use for equality is the double equal symbol. So right here, we are checking if the guess is equal to 1. If the guess is equal to 2. And I've also used these less than or greater than operators. And as it turns out, there are a number of these different operators that we can use in C, as in other languages. And we'll see these more in detail when the time is right. But here are some of the most common operators in C. We have the plus or addition, and we've seen one example of this when we just added 2 numbers together and stored the answer in a variable. Then we have the minus or subtraction. We use the star for multiplication. We use a forward slash for division. And this one you probably won't be too familiar with, but in C we use the % symbol to represent the modulo operator. And in simple terms, this operator is just going to return the remainder if you divide two numbers. We have the double plus for increment, the double minus for decrement, and these will either increase a number by 1 or decrease a number by 1. And we'll see examples of how these are very useful. We also have the less than or the greater than that we've already seen. However, we have less than or equal to, greater than or equal to, and then we have these two bars. These two vertical bars are going to represent a logical OR, and this key is right above your enter key. Next we have the two ampersands, and this will represent a logical AND. And finally we have the exclamation mark, which most programmers pronounce bang, and this is going to represent a logical NOT. There are others that we'll look at, but these are some of the most common that you'll use when building out these Boolean expressions. This is going to wrap it up for this video, but to summarize, we now have the ability to make decisions in our code depending on some question or Boolean expression. And these conditionals are a fundamental concept in programming. It's very important that you understand these, and we'll get plenty of practice using them. However, I encourage you to play around with the concepts that we've learned thus far, and post questions if you run into something that doesn't quite make sense. If you've been hitting some bumps in the road, that's completely normal, and the more practice you have, the better you're going to become. So keep striving and keep learning. In the next video, we're going to be looking at another fundamental building block of programming, the loop. And loops are going to allow us to perform some operation over and over again. If you think back to our dictionary example, you might be able to see how we were using a loop to keep asking the question, is the word on the page? And if not, we flip the page, and we ask again, is the word on the page? And we kept asking this question over and over again until we either found the word we were looking for or we ran out of pages. And if that's the case, we could determine that the word we're looking for is not in the dictionary. Thank you all so much for watching. I hope you're learning a lot from my videos, and I look forward to answering your questions. If you found this video valuable, make sure to hit the thumbs up so that I know you want to see more content like this in the future.